And that works out to this guy here, which I will run out of space promptly. So I'm going to try to factor out as much as I can. Take a 4/13. Giving me 2 minus 3, which is 4√13/13. Okay. One more example. Now we're not looking for a distance, we're looking for a point, the closest point, or the point on the plane that is closest to this guy. So I'm actually not going to use a projection this time. I'm going to draw a picture and think of this in terms of an intersection of a line and a plane. So let's call this point A. Let's just say A is here. Here's my plane. Now I'm looking for this point B that is closest. So what I think I should do, what my opinion is I should look at this line that goes like that. Think about that line, right? And find the intersection of this line L and the plane P. How can I have the plane P? I just need the line L. What is the line L? Well, L has direction vector. Well, what is the direction vector for this line L? Well, L is perpendicular to the plane. So if I have the, say I have the origin sitting over here, it doesn't matter. Let's say the normal vector is going, like that, or maybe it's going like this, doesn't matter. But it is pointing in the same direction as L. So that can be my direction vector. So N, which I can read from the coefficients here, it's 1, 2, 3. So I have a direction vector for my line. And then what else? I need a point that is on L. Well, the point, I don't have B, but I do have A. So the vector 0A, which is 1, 1, 3, is on L. So here's the idea. B, the desired point, is the intersection of P, and L. And remember, you can write L as just a vector that is on the line plus parameter times direction vector, 1, 2, 3. And again, 1, 2, 3 is the normal vector for my plane. So therefore, it is a direction vector for my line. So what am I doing here? Converting this into equations. X here is equal to the vector x, y, z. So if I take my line and write it in terms of its what's called parametric equations, I get this. So I think I said this before. These are the parametric equations for L. And what I'm going to do is I'm going to plug these into my plane, which was what? Equals 4. So I'm going to take these. Let's go green. I'm going to take these and plug them in. And then solve for t. So x becomes 1 plus t. Y becomes 1 plus 2t. 3 becomes 3 plus 3t is equal to 4. So my t, I get 1 plus 5, 14t. 5 plus 9 is 14, yes. And the constant is 3 plus 12 is equal to 4. So 14t is equal to minus 8. T is equal to minus 4 over 7. That is not my answer. But I'm just going to take that t and plug it in up here to find x, y, and z for the point B. So was it x is equal to 1 plus t over 7. Y is equal to 1 plus 2t. Minus 1 over 7. Yep. And then z is equal to 3 plus 3t, which is 21 minus 12. 21 minus 12. 21 minus 12 is 9 over 7. So B is equal to 3 over 7 minus 1 over 7, 9 over 7. Okay. As an exercise, redo this example try to use projections. Notice I avoided using projections altogether here. Why don't you try using projections? See if you can come up with this point B.